Artificial intelligence is a broad term in today's vernacular. And what may be artificial intelligence to one person might not seem like it to somebody else. I'd like to explore what AI means for us in the construction business. So let's just set the stage. We live in a rapidly expanding world that over the course of the next few years, by 2050, will be reaching a population of 10 billion people, and 2/3 of them will live in cities. In order for us to accommodate those 2/3, we're going to have to build 13,000 buildings a day. And to give you perspective, Dubai, which is, quite an energetically constructive city, is building 8 or so buildings a day. To add to that, we're going to have to build roads and rails that would circumference the Earth 30 times every year until 2050. So that's compounded by the fact that we live on a planet that has limited resources. And if we think about it, the construction business consumes a lot of energy. So 30% of the world's solid waste is attributed to construction. And the built environment uses 25% of the world's water, or consumes 25% of the world's water. And overall, the built environment uses 40% of the energy that we create on Earth. So my first case is the use of artificial intelligence to optimize the preparation of a plot of land for construction, which is grading optimization. Preparing a plot of land, we have to move a lot of material around to set it up into to plots or to prepare grounds for roads and so forth. This requires a lot of energy. And our first application is one included in as part of our civil package called Optimizer, which runs 15,000 or so iterations of the best way to maneuver Earth and help us save the environment and help contractors save a lot of money. Another application this is something that is very interesting. Some of you might recognize the Museum of the Future. So iconic projects like the Museum of the Future help us drive the need for artificial intelligence. And in the case of the Museum of the Future, it was an iconic design with thousands of panels made out of stainless steel with Arabic calligraphy on them, all, assembled like Lego onto a structure. So that structure is extremely important and a large part of the building. So you can imagine these steel calligraphy panels are heavy and quite complicated. The organic freeform required optimizing while keeping to the design intent of the architect, Sean Killer. Bureau Happold need to reduce the weight to keep the environmental impact to a minimum. So Bureau Happold solved this challenge by using automation. The structural 3D model was driven by an algorithm. There was no human modelers modeling the structure, and the resulting 9th automation design was significantly better than the original. Easier to construct with 40% reduction in the number of nodes and joints. It used less material with 30% reduction in weight, and truer to the original design intent with smoother curves. There were no modelers building this structure. Speaking of 3D models, this is the complexity that they were able to generate. They had designers and engineers across 12 different time zones working on one BIM model. Bureau Happold used the virtually infinite computational power of the cloud to simulate the performance of the building. One simulation was around the flow of the crowds in the building after an event. They ended up optimizing the location of the elevators based on simulation results. Next, Daiwa House, a developer in Japan, also relies on generative design, a subgroup of artificial intelligence, to do more with less. Land for development in Japan is very scarce and expensive. That's why Daiwa House worked with us on a generative design algorithm that can generate the best design for a certain plot. The algorithm takes into account some local requirements and regulations like setback, road edge requirement, and parking allocation. It also considers softer criteria, such as the line of sight for the apartments or the comfort of the occupants. And whereas one person can generate and evaluate one design at a time, the AI algorithm can do hundreds simultaneously to maximize Daiwa's return on their investment for buying and developing the plot. Generative design then shows the best solution it generates and evaluates and highlights the ones with the best ROI. Ultimately, it's up to the human to look at the variation and pick up the best for Daiwa House, the occupants, and the broader community. We also use our technology on ourselves. In October 2017, we moved to the new Toronto office that we designed using generative design. We wanted to maximize productivity while creating a great environment for people working there. We surveyed our employees and captured their performance and work habits. Do they prefer being next to a window or a meeting room? Who do they work with most? Do they want easier access to the bathroom or to the coffee machine? Do they prefer natural light or artificial light? Interestingly, it's a research office, so most of the scientists wanted artificial light so they could see their screens better. We translated this data into a mathematical computational model by an algorithm to minimize distractions, maximize outside views, prioritize personal relationships, maximize sunlight, all while taking into consideration a hard set of constraints like the boundaries of the building and the fixed location of the kitchens. The algorithm started doing its magic. It was analyzing the floor plans, modifying them, checking if the modifications made them better, and generated thousands of alternative options for the floor plan. The best were highlighted, each with its advantages to fit the criteria, and one was selected. Just to close the loop, the employees at the Mars office have an application that they can use daily to gather information on how design of the office affected their day. Next, let's talk about machine learning. I see the clock ticking out. Machine learning is a subset of artificial intelligence that lets algorithms learn by being exposed to data. One of the best examples of machine learning is that being used by automotive driving. Self-driving cars aren't built on normal programming if-then statements. They're built on insights. Machine learning focuses on the principle of driving. The car actually senses the environment and responds accordingly. And while the car responds, it's learning. When one system learns, every other car learns, enabling capturing more insights at an ever-increasing rate. But it all starts with sensing the environment and recognizing patterns. In a similar way, Construction IQ learns from Autodesk's CDE, which is Common Data Environment. IQ can look at all project data, models, emails, issues, pictures, RFIs, etc. It analyzes this data and both quantitatively and qualitatively to identify project risks, to help potential failures. It highlights areas that require attention. And the insight for Construction IQ is gathered anonymously from all projects around the world that opt in. The Red Sea Development Project in Saudi Arabia was one such project. For example, when on projects using a certain manufacturer for window frames that lead to leakages, it turns out that the installation was done by a certain subcontractor. This is information humans may miss on, but machine learning algorithms would catch. This is a real-world data presented opportunity for construction companies, an opportunity to better predict and manage risk. We built Construction IQ using over a decade's worth of construction data. And with these tools, Royal BAM applies machine learning and predictive analytics to spot the patterns that predict huge risk issues and keep their site workers safe and productive. In addition, Royal BAM incorporate data from other sources, combining it with their common data environment. Today, the job site managers at Royal BAM are more productive. They close out quality and safety issues 20% faster. Royal BAM now has better insight into to ensure less rework, making their sites better, more predictable, more productive, and more profitable. The sites are less risky for their workers and for their businesses. Another algorithm that our platform can be used to perform is to look for such specifics as a laborer's site and highlight who's not wearing high-vis vests, gloves, or hard hats. It can actually look at photos of scaffolding and highlight if the scaffolding does not look secure. This is a building, is one of the headquarters of Schneider Electric in France. It looks like a regular building, but it has sensors embedded throughout. The sensors constantly monitor things like temperature, humidity, light, and even noise. The sensor data is overlaid on BIM, and virtual reality model serves to create a digital twin of that building. The operations teams uses the digital twin to monitor the performance of the building and to plan their maintenance work. But it does not end there. A digital twin can use AI and give us insight on the behavior of people in the building. One finding, for example, if the temperature in summer exceeds a certain threshold, people spend a lot more time in the cafeteria. I'll not presume that Schneider are limiting their AI analysis, but I will venture a guess that this building will be one of the most efficient and least expensive buildings to operate over its lifetime, something it will get better at with time. We spoke today about artificial intelligence in a variety of ways. One of the trends that seemed impossible a few years ago is now shaping the future of construction and will become the norm. My message today is to get ready by reimagining the way you do things. Thank you.